Hello, my friends. It's Nick, the ASMR nerd, and today I'm going to show you the process of building a custom mechanical keyboard without any of the scary stuff like soldering. The process you're going to see today is something that anybody can do without any prior experience. All you need is a bit of preparation, a few hours to put it together, and a bit of patience. Now, why would you want to build a custom mechanical keyboard? After all, you could just go to the store and pick up a fully assembled keyboard from any of the major manufacturers. But there's two main reasons why you might want to build your own. The first is that it's going to sound and feel better to type on. The typing experience will be way better than you could ever get from one of those pre-built keyboards from a major manufacturer like Razer or Corsair, for example. The second reason is that you can make it exactly the way you want. You can pick the layout you like, the case, the switches to feel and sound just the way you want. Of course, the keycaps to look the way you like. You can customize it to be exactly the keyboard of your dreams. So, the board that we are going to build here today is a relatively high-end board, but all these principles apply to a board at any price point. Today's components are provided by Drop. They have supplied us with a Barebones kit for their Shift keyboard. So a Barebones kit comes with a case, a PCB, which is the circuit board, and stabilizers, which sit under the longer keys and prevent them from wobbling too much. Now, you can, of course, buy all those parts separately if you like, if you have specific ideas about what you'd like, but the benefit of a Barebones kit is it supplies them all together, cuts down on a little bit of the guesswork and sort of compatibility, figuring out that sort of stuff. So I think a Barebones kit is a great way to start if this is your first mechanical keyboard. So in addition to the components that come in the Barebones kit, that is the case, the PCB, the stabilizers, you're also going to need a few other things. You're going to need, for example, switches. And switches sit under every key, and they are what confers the feel and the sound when you press down on the key, or at least a large portion of what confers that feel and sound. The other components play a role as well: the material of your keycaps, the material of your case, and other aspects. But for switches today, we have been supplied with these ones right here. This is a Halo True switch from Drop. Once again, it's what we call a tactile switch, which means that it's neither super clicky sounding, nor is it completely linear and smooth in its action. It has a little bump right up at the top, and it's a great compromise for people who don't want something that's too loud, but also want something with a little bit of a bump, a little bit of feedback. It's a nice middle ground. You might be familiar with brown switches, like Cherry MX Browns. They're a very popular tactile switch. So Halo True switches are kind of a relative of a Cherry MX Brown. We will look at these more when we get to the point where we're installing them. But if you'd like to learn more about switch types and picking the right switch for you, I've got a video that discusses the major types that you can check out here. I'll put a link just up there. You can go check it out if you're curious. So we've got a complement of switches right here. And the other thing you're going to need is some keycaps. Some keycaps. So for keycaps, we have these right here. The GMK Red Samurai keycaps. As the name suggests, these are samurai-inspired keycaps. They come in a lovely deep red and dark gray colorway with gold accents. They're made by GMK, which is a German manufacturer known for precision quality keycaps. Once again, these were supplied by Drop. This is a collaboration with Drop, so thank you to Drop for supplying all of the components that we're using here today. So aside from those things, the Barebones kit, which includes the case, the PCB, the stabilizers, and then the switches and the keycaps, really the only other thing that you're going to need is a screwdriver, because you're going to have to put together a few pieces with the case, probably screw down the plate, these sorts of things. So after that, you're basically good to go. However, today we're going to be doing a few extra steps to make the keyboard feel and sound really nice. We're going to be lubing, clipping, and band-aid modding our stabilizers. This is, in my opinion, and the opinion of many others, perhaps the most important modification that you can make to a keyboard. And it really does make it feel and sound much nicer to type on. So for that, you need a handful of other things. And now, this might seem a little scary, but it's really not. You need a high viscosity grease, like a dielectric grease. You need a lower viscosity grease, like a synthetic grease, like this one right here. You can pick either of these up at the hardware store, just your local hardware store, probably for maybe $5 a tube. There's also greases specifically made for this kind of thing for keyboard enthusiasts. A very popular one is Krytox 205G0, and you can get that if you like as well, and use it for in place of both of these if you want. But I'm just going with these because they're cheap, plentiful, and locally available. You're also going to want a paintbrush to paint on your grease onto your stabilizers. You're going to want some clippers for clipping your the feet on your stabilizers, and you'll see what that means when we get there. But you need these to be able to cut little pieces of plastic flush. And if you're going the whole way and you're going to band-aid mod, which again you'll see what that's about. It's about dampening the bottom out sound. You're going to need a few normal sized band-aids and some scissors just to cut them into little pieces. This all sounds a little mysterious, perhaps, if you've never seen this process before, but you'll see what I mean when we get there. Okay, so with that out of the way, let's start opening some of this stuff up and assembling our parts. So, to start with, let's open the drop shift. So, the shift is an interesting keyboard. It is what's called an 1800 layout keyboard, which is fairly uncommon as they go. Basically, it packs in all the functionality have a full-size keyboard in a smaller, narrower footprint, which is more ergonomic and space-saving. So let's take a look at the Shift Barebones kit here. I'm gonna have to open up this seal right here. Why is this so difficult? There. Let's see what we have inside. And there we are. So inside we've got a reference card that has keyboard shortcuts on it for LED control, media functions, all these kinds of things. On the back, a bit of information about getting started. The warranty, which I believe is a 1-year warranty, I think. And just that sort of general information. The Shift is, of course, available as a fully assembled board from drop as well, should you want to go that route. And they do have a handful of customization options when you buy it there, like what kind of switches you want. So that's absolutely an option. But if you really want to go the full custom route, you can buy the Barebones kit, which is what we have here. The Shift has this gorgeous aluminum chassis. Let's just pull it out, take a look. If you have been watching my channel for a while, you might remember my review of the Drop Control, which is a close sibling of the Shift. It's like the Shift, but a bit smaller in the 10-keyless layout. Both of them come with this low-profile CNC machined anodized aluminum case, which is very nice, very hefty, has a nice weight to it. It's finished very nicely with these chamfered edges all the way around. And comes packing edge lighting. So all the way around the edge here, we have a plastic strip, which is actually part of a plastic diffuser on the inside that emits light around the edges. And of course, underneath each key in each socket, we have an LED as well. So the keys are individually backlit. They are controlled either using the board itself or using the GMK open source keyboard software. This keyboard is fully programmable with GMK, which gives you a lot of flexibility. A lot of flexibility. So, it says drop shift on the back here. Some basic information. These spots here are to accommodate the feet, which will prop it up at an angle should you want to do that. And we'll see those in a second. So these are the stabilizers of which I spoke. You will notice that as this Barebones kit comes from the factory, they are pretty rattly. Pretty rattly. There's no lubrication. There's no dampening. So some of the modifications we're doing today are going to be to address that rattle. All right, let's put that aside for a moment and just take a look at what else we've got in here. In the box, we have a handful of other items. We have a keycap puller, which will allow us to remove the keycaps if we need to do so. We have a very stubborn switch puller, which will allow us to pull switches out again should we need to. We have a pair of magnetic feet. These are angled feet that just go on the bottom of the board, and they prop it up at a slight angle, should you prefer that kind of typing experience instead of the flat board. And finally, we have a cable, USB-A to USB Type-C. This board, we didn't really look at it, but this board has two USB Type-C ports, one here and one here. You can use either as the connection to your PC, and then the other becomes a USB hub, which is pretty darn handy. So that is everything in that package. So let's put this here, put this back here. Put the whole box aside. And get to the process of opening this up. Now, if you don't want to do the lubrication of the stabilizers and the Band-Aid modding and all that, you can actually just skip this step entirely. You can leave this assembled as it comes, and you can just get on with the business of popping switches into their sockets. Very important to note that if you want to install your switches without soldering onto the board, you need a board with hot-swappable sockets. That's the key term, hot-swappable sockets. That refers to these sockets that allow you to just pop a switch in like so. If I can do this. Do I have it lined up right? I do. Like so. And then pull it out like so. Just grab it and pull. There you go, like that. So, hot swappable sockets are the critical thing there. Of course, this board comes equipped with them. Many boards these days do. Many Barebones kits and PCBs are sporting hot swappable sockets. It's actually becoming much more widely available than it used to be as a feature. But anyway, we'll get to the switches shortly. But first of all, we have some work to do. So let's open this thing up, shall we? This is why we brought our screwdriver. So we're just going to have to pull out a few screws here. Shouldn't be too difficult. I've got here a one of these will work. There we go. It's just a little magnetic pad that allows you to keep your screws secure. It's actually really, really handy. They often come with repair kits or screwdriver kits for electronics. So I think we've got eight screws that we're going to need to remove in total here. All right. And voila. There we have the back side of the PCB. This plastic piece here is that diffuser layer that I mentioned to ensure that the edge lighting is nice and even all the way around. These metallic pieces that sit in it here are to provide a spot for those magnetic feet to magnetize onto. So that's that there. Underneath, we have the PCB. But before we pop that out, actually, this is something I should have done before. We're going to have to take out these stabilizers, I think. Oh, no, never mind. They just come out. Okay, so we'll just drop the PCB out like that. We can just put it over here. As you can see, it's got the USB Type-C connectors on either side there. On the back, you can see all of those hot-swappable sockets and a few logic controllers, the chips that control the keyboard scattered across there. And of course, lots and lots of LEDs. These ones right here, one for each key, and then a bunch around the margin as well for the edge lighting. If you're going to be handling a circuit board, just make sure that you're handling it from the edges, like so. Generally, these things are pretty durable these days, but you want to try and avoid touching a lot of the surface components if possible. So we'll just put that right here for now. Okay, and then we've got the top plate here, which houses the stabilizers. They just kind of snap in to the top plate. And there's two different kinds of stabilizers you might come across. Most of them that you'll encounter will snap in like this. There are some that you might find that also screw in to the printed circuit board, but they are less common in my experience. So if we turn this over, we can see more detail of these stabilizers. They have these wires here that connect the sides, and that's what provides the stability for those long keys. So what we're going to be doing is lubricating, as I said, clipping, which you'll see in a moment, and band-aid modding these stabilizers. So first of all, let's pop them out. The easiest way to do that is to look for the little lever. There's usually a little lever there somewhere. Yeah, you can see right up. Hopefully you can see anyway. On the top edge here, there's like a little, there, that's probably better for you. A little lever that you can kind of push in. And that should allow the top to kind of rotate out. So we should be able to just push that little lever in and then push up from the bottom to kind of pop the top of the stabilizer out, like so. You can do the same thing on the other side. There. And then the whole unit just comes free, like that. So put that there. We'll do that for all the rest. Should be fairly straightforward. Again, you don't have to go through this step if you don't want to modify your stabilizers, but I really, really do recommend modding your stabilizers, or stabs, as you might see them called in the community, because people are a little lazy, like to use shorthand. You'll notice on the space bar, they're actually the other direction compared to the other keys, facing the other way. I mean, with the clips on the bottom side instead. Put that there. And finally, because this this is a full-size layout, more or less. The 1800 layout. We do have a numpad over here with stabilizer on the enter key. There. And there. That comes out there. Awesome. Okay. You can see it's a really nice, durable, thick aluminum case. I really like drops cases. Okay. Let's just move this whole thing aside for now, because we're actually not going to be doing anything with the board for a little bit. Instead, we're going to be focusing on these stabilizers. So, each stabilizer is made up of these two plastic units on the side and this metal bar connecting them. And first thing we're going to do is snap this metal bar out of the plastic bits. So let's just hold one side, you turn the bar 90 degrees, pop, just comes out like that. Oops. You can do the same with the other one, other side. There we go. Oh, you know what? I'll be darned. These are a little bit lubricated. They actually have come pre-installed with a bit of lubricant. You can see it on my finger there, probably. So I don't know if this is something that Drop has started doing recently, but I don't remember it being the case for their control keyboard. Nevertheless, the amount of lubricant that's on there is quite paltry. You can see there's a little bit on there. But as you heard before, it really doesn't prevent these stabilizers from rattling something fierce. So we're gonna do a better job ourselves. We're going to do a better job. So each of these plastic bits is made up of two pieces, and what I'm going to do here for you is bring out a piece of paper towel so that you can see these a little better, contrasting against the white background there. But each of these plastic side pieces here is made up of this sort of housing piece, as you can see here, and this stem piece that sits inside. So the first thing that we're going to do is we're going to clip the feet on this stem piece. I'm going to show you here what I'm talking about. So this, when you press down on a stabilized key, this little piece goes down like this, and it impacts with your printed circuit board, your PCB. And the feet here that are doing the impacting, they have these, this is going to be very hard for you to see, I hope you can see it, but they have these little feet, little prongs on them. You might be able to see it there. These little prongs, this prong, oops, this prong, and this prong. And they're not actually necessary. Originally, perhaps once upon a time, they are intended to help with the impact, but really they just add to the unpleasantness of the sound and the feel. So we're actually going to snip those right off. So that's what we brought our flush cutters here for. So all we do is we find those feet with the little prongs, and we cut like so. I'm sure you guys can hear the birds outside. That's because I'm filming this at an ungodly hour, but that's when it's quiet here. Or it was quiet, but now the birds are here, so you guys just are going to have to live with a bit of bird song. There goes the other one. And then we just want to make sure that this is nice and flat If you look at it, there's no bits of plastic, no plastic spurs sticking out or anything like that. Looks nice to me. Looks good. Okay, so the next thing we're going to do is we're going to apply a bit of lubricant to this housing. This housing here is what holds this stem piece, of course. It just goes inside like so. And so let's... Gosh, those birds are loud, aren't they? Let's take our synthetic grease here, our lower viscosity synthetic grease, and we're just going to dip our paintbrush in here. Get a little bit on it, just enough to kind of coat the brush, just a bit of a blob. And then we're going to just paint the insides of this here housing. Unfortunately, these stabilizers on this board are black, which makes it very hard for you to see what I'm doing. I didn't consider that. But really you just want enough for there to be a thin film. What you're trying to do is reduce the friction between the housing and that little sliding stem piece. You don't want it to get all gunked up, just enough to reduce the friction. Stop it from rattling around in there. And really, that's kind of what drop did to start with, honestly. So this part is maybe not as necessary. But the next piece that we're going to do is something that drop has not done. So anyway, so now we're just going to make sure this slides back in here comfortably and it doesn't rattle around. Now there's a directionality to these little stems, and normally you can tell because if you look in here, there's like 2 holes on one side, 1 hole on the other. It doesn't really appear to be the case on these particular stabilizers though, and you'll find that different stabilizers all look and are structured maybe slightly differently, but generally speaking they're the same. Yeah, this looks kind of identical from either side, truth be told, so it may not matter which way it goes in. I'm not positive. Nope, there's only one way it goes. I'm pretty sure. And it's that way right there. You might have to experiment with it depending on your stabilizers. The best thing actually to do is pay careful attention to how they go together as you're taking them apart. That always helps. So we're going to clip and lube the other side of the stabilizer here. You can see some of that lubrication that drop puts on there, right there. Again, it's not a lot, but it's a bit. There's one little prongy foot. There's the other. And let's make sure that the bottom of our stabilizer looks nice and flat. And it does. It does. So now we're going to take a little bit more lube. And we're going to use it. This may be a little more than we need. We're going to paint it on the inside of here until the whole inside is thinly coated. Just thinly coated. Okay, that's good. Now we can take our clipped stabilizer and clipped stem, stabilizer stem, I suppose. There we go. So it should slide smoothly without being super rattly in there. I think that's pretty good. Unless it falls out, it's not very useful. Maybe we'll use a little bit more lube in there. Just a little bit more. These stabilizer stems are a bit looser than other stabilizers I've used, so it might require a bit more lubricant in there to prevent them from rattling around. How was that? Did I put it in the wrong way? I think I did. Yep, there we go. Yes, that feels great. That feels nice and smooth. Good freedom of motion without too much rattle. So that's an improvement there, I would say. It helps to have a little bit of Kleenex or paper towel just to wipe up with as you're moving along, because the lube can be a little messy. Okay, now we're going to pull out our slightly more viscous lubricant here, the dielectric grease. Again, if you're using something like a Krytox 205G0, you're probably fine to just use it for both of these steps. But so what we're going to do here is we're going to take the wire and we're going to dip it in, and we're going to dip it in just past the elbow, like so. And we're going to get a nice glob of this lubricant in there. And the idea with this, get it nicely coated. It might be a little bit much, but you know what? We'll try it out. The idea here is that you want to stop, you want to prevent the wire from rattling around in its sort of clipped in position here. So now all you're going to do is line up the wire with the hole in there, which is sometimes easier said than done, but it should be doable. There we go. And then just snap it back into place, like so. So it's quite a bit of lube in there. The trick here is you don't want to use so much that it restricts movement, but you don't want to use too little so that you still have rattle. I think that's not too bad, actually. See, this is the motion that we're looking for, like so. See, that stem kind of pops out the top there, and it doesn't sound noisy at all, does it? So let's do that now. Now that that's in there, take this, stick in the other side. Give it a nice hefty coating just a little bit past that elbow. About like so. That's pretty gooey. There. And we find our other stabilizer here, or other half, I should say. And you just kind of slot that into that hole in that stem and snap it back in. There we go. One fully lubed stabilizer. And I'd say we've got pretty good motion on both sides there. Doesn't feel too gummy, but doesn't sound loud at all. So that's pretty good. Pretty happy with that. So I will remind you once again, this step is entirely optional, but I do highly recommend it. It's a bit messy, it's a bit finicky, but it's totally worth it because it's going to really improve the sound of these stabilizers. So I'm going to go and lube the rest of these, and then we will move on. We'll clip and lube, I suppose. Then we'll move on to the Band-Aid modding. And here we have our lubricated stabilizers. Hopefully not over-lubed. I was careful to put on what I thought was the appropriate amount, but it's sometimes hard to get it just right. It can take a little bit of trial and error. Really, what you're aiming for is to make sure that all of the parts move smoothly with as little friction and resistance as possible, while also kind of plugging up some of the gaps and those areas where plastic meets plastic or metal meets plastic, so that they're not rattling and moving around in a way that's loud or clattery or annoying. So it takes a bit of practice to get the feel down, and I hope that I've nailed it for these ones. We'll find out when we get to the typing test. But the next step, of course, is to put them back into the plate. So let's just pull these up out of the way, like so. Bring the plate back, front and center. And again, these are plate-mounted stabilizers, so we should basically just be able to snap them back into place, like so. We know that the bar, that piece of wire, has to go under the plate, so we just tuck that under the plate, and then we snap the top halves back into place, and there they sit. That should work out pretty well. Theoretically, these ones, you know, this, and this, they're all the same size. They're literally the same stabilizer, so you don't have to put the exact one back in the exact same place. But I like to keep them that way just because, I guess. But yeah, they're all identical, so it doesn't matter so much. The only different one, obviously, is the space bar. That one has to go in the space spot. Because it's the only one that'll fit there. Here we go. And last one over here. Or last of these small ones, anyway. Oops. Okay, there and there. So just right away, you can hear they're a lot less rattly. There's a bit of rattle there, but it's way less than there was. So that's pretty good. And then finally our space bar here, which we're just going to tuck in right like so. Very good. Very good. Yeah, those are feeling a lot better. And hopefully that will be apparent when we type. Hopefully they feel nice. So the next step that we're going to take here is the Band-Aid modding. And it's called this because that's literally what we're doing. We're putting Band-Aids onto our circuit board, which sounds a little bit silly, but trust me, it makes sense. So what we're aiming to do with this mod is to dampen the sound and the feel when the stabilizers, so the little feet on these stabilizers, when they strike the PCB. And in order to do that, we're going to use a Band-Aid, probably a couple of them. I find that cloth Band-Aids work best for this, but you could use a plastic one as well. I just find the fabric ones provide a little bit of, I guess additional thickness or something. But really, this mod is entirely up to personal preference. Maybe you prefer the harder bottom out right on the plastic. If that's the case, then don't sweat it. Just leave it as is. You can move on to the next step. But if you want a more dampened feeling bottom out, then this is what you can do. So, I'm going to start by opening up our Band-Aid here. Put that aside, and this is where the little scissors come in. We're going to cut up the Band-Aid so that we can cut it into little strips, little squares. You just need them to be big enough, just big enough to cover the area under the foot of each of these stabilizers. So again, when it strikes, it's striking the little square of Band-Aid, or little rectangle of Band-Aid. That's all. So I find it's a little easier to actually do this after you take off the adhesive covering there, because if you cut it up first, then sometimes it's hard to get the backing, I guess you call that, the backing off. So I usually cut these into strips about that wide, like so. Just put the rest of it there for now. And then, depending on, we could probably, well, you know what, let's just make it easier on ourselves. Having bigger pieces of Band-Aid means you don't have to be as precise in your placement. So speaking of placement, it's a little bit tricky to figure out where on this PCB we actually need to put these little pieces of Band-Aid, because there's no markings or cutouts or anything. On some circuit boards, you'll actually have like little rectangles that delineate where those stabilizer feet are going to strike. Not the case here. However, I can actually see little smudges left behind. Can you see there? Little smudges left behind by the factory lube on those stabilizers. Remember, there was a little bit of factory lubrication on there. So that gives us a pretty good target for our Band-Aid here. What I'm going to do though is I'm going to just wipe up that lubricant just so the Band-Aid sticks properly, and then I'm going to replace that spot, or cover that spot, with a little bit of Band-Aid. I think that's about right there. And we'll do the same thing over here. One of the tricky things about this whole process is that you don't really get to test out what this sounds or feels like until you've put everything back together. Until you've put your switches in and your keycaps on and all that stuff. I mean, you can do it with just the stabilized keys to find out just how it feels on those ones, but you still have to screw it all back together at least to get to that point. So that's a little bit unfortunate, but I think those are about in the right place. It doesn't have to be beautiful, because no one's going to see the circuit board once it's all assembled, but it just needs to be positioned correctly. These pieces are taller than they need to be by quite a wide margin. You could have probably something half this size and still have them be effective, but it's just a matter of making sure you've got them in the precise right spot. This way, if it's a little low or a little high, it doesn't matter. And then the other thing that some people do is some people will take a bit of their lubricant and they will lube the Band-Aids, the Band-Aid strips here as well. I find that that's a little bit unnecessary, because there's lubricant that's already kind of coming out of the bottom of the stabilizers a little bit, just from the stuff that we put in there already. And I find that just leaving them dry like this is generally fine, but that's up to you. If you want to use your brush, take a little bit of your lubricant and just just paint it on there to soften them up a little bit. You could do that. Okay, well, I'm going to go ahead and do the rest of these, and I'll show it to you when I'm done. And we've got the Band-Aid strips on. You can see I actually readjusted these ones I put on initially, and it takes a bit of trial and error. Something that I didn't mention that can be quite helpful is taking the top plate like this and just placing it down over top of the PCB. Being careful about those USB Type-C connectors there. And just, if I can get it to line up here, there we go. And then you can just let it fall into place there. And you can see, kind of peek underneath and see if your Band-Aid bits or strips are falling under the stabilizers, and indeed they are for us. So that gives you some guidance there as well. Okay, well, we're done with all the stabilizer modding. So now it's time to put this thing back together. So we're just going to flip this over and reassemble it the way we, or the reverse of the way we initially took it apart. So this PCB just very carefully drops in like so. I believe that's correct. Yep, that looks good. The USB Type-C ports are aligned, and it feels like it's in place. Then we take our LED diffuser layer, and that's going to sit like so, just like that. All the screw holes align, so we've got it on the right way. Then finally, we take our back plate, the back of the case, I guess I should say, and we place that on top, like so. Make sure everything's aligned nicely. I believe it is. And then let's take our screws and screw it back together. So that whole adventure, that odyssey with the lubricating, the clipping, the lubing, the Band-Aid modding, it seems like a lot of work, and it is, additional work for sure. But I cannot stress enough how much it can improve the typing feel, even on a cheaper board. It can really elevate the typing experience to feel like something much more premium. Case in point, I went and clipped, lubed, and Band-Aid modded the stabilizers for my RK68 from Royal Kluge. They sent that over a little while back, and I reviewed it, and it's a neat little board because it's got a hot swap PCB, but it's only $60, and I wanted to see what kind of typing experience one could get out of it. And so yeah, I went and did all that stabilizer modding. I put in some dampening material. It's another thing you could do here if you really wanted. You could put in some dampening foam, but that can also dramatically alter or improve the typing feel. But that's a little trickier because you have to figure out where in this assembly you could fit it safely. You'd have to cut it to the right size and that kind of thing. So we're not gonna do that here. But anyway, I put a bit of dampening into the RK68, and it came out feeling really good. You're only going to get so far on a board like that because the plastic case is ultimately going to confer a certain typing feel, no matter what you do. But even still, I was quite happy with how the stabilizer modding and dampening helped the typing feel for that board. I also put on a bunch of different switches and different keycaps and stuff. That, of course, also helps. Okay, so we have reassembled our board and we're back to where we started, essentially. But again, listen to the difference. Remember that rattle that we heard at the beginning on these stabilizers? Pretty rattly. Let's listen now. I think that's quite a bit better. It's not perfect, but it's going to be way better. So the next step here then is to put in our switches. So as I demonstrated or showed you briefly earlier, we are using these little switches here. These are Halo True switches, and they're designed to feel like top ray switches. Top ray switches. Top ray switches are a very interesting mechanical switch that actually use rubber membranes. They are electrostatic capacitive switches. Electrostatic capacitive switches. And they have a unique kind of pop feeling to them because they have these little rubber domes under each switch that invert to actuate the switch. And so this is a sort of a mechanical take on that style. It's kind of funny that someone would want to, emulate a mechanical switch which uses a hybrid membrane tech in a pure mechanical switch, when really, for many people, the whole point of this is to get away from the cheap-feeling membrane actuation that you get on the inexpensive non-mechanical keyboards. But many people really like the feeling of top-ray switches, that pop that you get. And so that's what we've got here. And I'm very curious to try it out at the level of the whole board to see how typing on it feels. Halo Trues have very little pre-travel, which means you basically don't have to push down much at all before you get that tactile event, that bump, that pop, so to speak. It's a very rounded and relatively reserved kind of tactile event. And in terms of the weighting, Halo Trues are weighted at about 60 grams for their maximum force right at that tactile bump. But they bottom out much heavier. The very bottom of their actuation, when you hit the bottom, is about 100 grams. So these are the type of switches that you really don't want to be bottoming out, or you're going to tire your fingers. So the Halo Trues are intended for people who probably aren't bottoming out their keystrokes, by and large. Certainly that heavy bottom out will discourage it. You really just want to get just past that tactile event, just past that bump. So that's where the actuation occurs at about 1.9 millimeters, just after that round bump. It's a very broad, round, tactile bump. In terms of aesthetics, they're not the prettiest switch I've ever seen. They've got this kind of salmon or peachy colored stem, and then this transparent upper housing and opaque lower housing in white, but they feel very interesting, so I'm curious to check them out. The action is nice and smooth, and there doesn't seem to be too much stem wobble, just a little bit. So they are, of course, 3-pin. So we have a 1-pin, 2-pin, and then this big guide pin in the middle. These two here are contact pins, and they slot into the sockets on the motherboard naturally. one thing to consider when building a custom keyboard is that there are also 5-pin switches that have additional pins right here and right there. As a matter of fact, I think I have an example of that. Let me go grab it to show you. So this is a Boba U4T switch from a company called Casio, or I should say a creator called Casio. It's actually manufactured by Otemu. Anyway, it's a tactile switch as well, and it's a 5-pin switch. You can see here we have the 2 contact pins, the guide pin in the center, and then 2 additional pins here, 1 and 2. And these are here to allow it to mount directly to a PCB, rather than the plate mount setup that we have here. Now, in some cases, that can be a problem, because if you were to try and mount this switch into this board, these additional pins on either side would actually prevent you from doing so. Some hot swap boards have holes to accommodate those additional pins. This board does not, nor does the drop control. That's something that I do wish the drop would add to their series of boards. But what you do in that case is you simply trim them off if you really want to use 5-pin switches in a plate mount setup like this with a board that doesn't accommodate 5-pin PCB mount switches. So that's a bit of extra work if you were to go that route, but it is an option. But for maximum compatibility, to keep things easy, you're looking for 3-pin plate mount switches if you are going to be using a board where the switches mount onto the plate rather than directly onto the circuit board. And most boards these days, are plate mount boards. Most boards that have hot swap sockets like this are going to be designed for a plate mount setup. It's generally preferable because it provides a more solid typing experience, because when you put pressure down on the switch, you're pushing down against the plate, which is usually a lot stiffer and better stabilized than the PCB, which can sometimes have a bit of flex to it, right? So anyway, that's a bit of a preamble, but the point is we're going to be popping these little bad boys into this board. And I demonstrated it earlier, of course, but it's very simple. It's very simple. All you have to do is take the switch, make sure that the pins are facing the right direction, so in this case, downward, and then you just line it up with the socket, and then you just push it in. You want to push evenly on kind of all 4 corners. You don't really want to push, say, the top in and then the bottom. You kind of want it to all go in at once, just like that. Easy peasy. Very nice. So let's grab the rest of those switches and start popping them in. Drop has provided us with 110 switches here, which is more than we'll need actually. This layout has 99 keys, I believe. 99. So you can order the Halo Trues from Drop in, I believe, quantities of 70, 90, or 110, and they're about 50 cents per switch, which for premium switches like this is a perfectly reasonable price. So they don't come factory lubed, so they come unlubed and unfilmed from the factory. That is if you wanted to elevate your keyboard to yet the next level. Lubing and filming the switches is definitely an option. And what that entails is disassembling the switch, so popping it open and applying lubricant on the interior to improve the smoothness of the action. And then filming is putting just a very, very thin gasket, actually, in between the top and the bottom casings of the switch, which is supposed to improve the tightness of the switch to ensure that the top and the bottom fit together very tight. There's no rattle, no wobble. But from what I can see here, the Halo Trues are actually very well put together, built to very tight tolerances, and I'm not seeing any wobble between the top and bottom case. But if you wanted, you could go and film them, which would tighten them up even further. But they're looking awfully solid to me. So, lubing and filming your switches is a very time-consuming process. The hobby is the kind of hobby where you get out what you put in. If you're willing to take the time to make all these little modifications, which they're not very expensive, and individually they're not very complicated, they just take a lot of time. If you're willing to put in that time, then you can get some really nice results and end up with a board that feels much nicer to type on than anything you'll pick up at the store. And the reason for that is not that manufacturers couldn't, clip and lube and band-aid mod their own stabilizers or lube their own switches or film their own switches. It's just that it costs more money to do so. And most of them don't, because most people don't know what they're missing out on, But the other reason being, when it comes to lubing switches, some people prefer the feeling of an unlubricated switch. So giving customers the choice makes sense. So there we go. One rail done. And we're just going to go through and populate the whole board with these switches. We're coming into the home stretch here with the switches. Just a few more to go. These switches, as I mentioned, are offered exclusively by drop. They're manufactured by Kale, also known as Kaiwa. Kale makes all kinds of other awesome switches. They're box series, which I'm a big fan of. But you could put any switches in a board like this, or really most hot swap boards. You should be able to put in pretty much any switches that you desire. These ones are priced at about 50 cents a switch, I think I mentioned. But you can get certainly more budget-oriented switches that are more like 20 cents a switch. Your Gatorons and things. Or really hyper premium switches that can cost $1 or more per switch, like your stuff from Zeal PC, Zelios and Telios and all that good stuff. The real trick is finding something with a feel that you like, which switch testers can be very good at helping to determine. I do recommend that if you don't have much experience with different switch types, that you order a switch tester and just try out some different types, see how they feel. And then, of course, you need to make sure that you have enough switches to cover your board. That's pretty critical as well. You usually want a few extra just in case there's a couple that show up non-functional, or maybe you accidentally bend the pins beyond repair trying to put it into the socket. Usually if you have an issue, you put it in the socket, the switch isn't working, or it feels like it's not seated quite right, pull it out and check the pins. They're often just a little bit bent, and you can bend them back in, pop it back in fairly easily. But having a few spares is never a bad idea either. And this switch over here is a slightly weird one. It actually sits rotated. You might notice that the socket is slightly rotated. So we're just gonna pop it in like so. And that's the last one. There we have it. Well, all our switches are now on. Our drop shift has been had its stabilizers modded and is filled up with some nice poppy tactile halo trues. It's maybe not the most aesthetically pleasing naked board. Some enthusiasts really like to color coordinate and make sure their stabilizers match their case, and that the colors of their switches are, complementing their case and their keycaps and all that. But the fact of the matter is, you don't see the switches once they're under the keycaps, so that's less important. One final thing to mention about switches that I forgot to mention earlier is that, these have the clear upper housings, the translucent upper housings. If you want to have RGB light that shines through, you generally want to look for those clear upper housings, or at least a switch with a gap or a sort of a window for the light to shine through. If you look here, you can see that there's this clear slot that sits just over the LEDs on the board to make sure that the LED can shine through and diffuse through the top housing of the switch. There are switches out there with completely opaque top housings. The classic cherry switches are like that. And obviously with the surface mount style LEDs on this board and most boards these days, that would obscure the light. So you do want to make sure that there is a window or a slot there for the light to shine through. And if you want maximum light transmission, you want to have this translucent upper housing. So there's a lot of little things to consider for sure, but generally speaking, most stuff is going to work together just fine. Just fine, as long as you make sure your board has wide hot swap compatibility, that you've got switches with the right number of pins, or you're willing to trim the pins if you have to do that for a board like this. If you were to be using the 5-pin switches that we looked at earlier, and that your LEDs can shine through, then you're in good shape. Those are the tricks. Okay, so let's push the board aside just for a moment, because now, finally, we're on to our keycaps, which for many people are the most fun part of the process, because they're the most visible part of the keyboard once it's complete. As I said back at the beginning, today we are using GMK Red Samurai, which are a cherry profile switch, which means that they're basically the profile that you're probably used to from keyboards for forever. That means they're the height and shape and feel that you're used to, but they're a little bit shorter, a little bit lower profile than the typical OEM profile, which sits a little higher. You'll see what I mean when we open them. But this front here, this box, shows us the colorway. It's this dark gray, this like deep, almost maroon red, and then this cool gold as an accent. I think they're going to look rad. These are produced in cooperation or collaboration with Drop, as you can see, and designed by a designer named Red Suns. Red Suns. They're manufactured by GMK, which is, I think I mentioned earlier, a German company that is known for many years of premium keyboard design, or pardon me, premium keycap designs. And their switches do tend to command a premium. Sorry, not switches. Why can't I talk? Their keycaps tend to demand a premium. They are very popular amongst collectors. And so for this set of switches, you pay $110. It's a little bit loud while I get the plastic off here. There we are. Yeah, so for the 1800 kit, which is the layout that fits our board of the GMK Red Samurai, you're going to pay $110. And the other kits are in that neighborhood as well. And there are some additional caps. We've got some fun accent keys here. And of course, we've got the characters on each cap, which is so cool. Here, let me show. Why is this so difficult? There. So, for each keycap, we have the Arabic numeral, or the Latin character, whatever it is, and then these Japanese characters. Now, pardon my ignorance, I am not super familiar with Japanese characters. I do not know which alphabet this is using. Maybe somebody could tell me in the comments. One of you can let me know. But it creates this really cool aesthetic that is complemented by this awesome color scheme. You can see that these keycaps are double shot, which means that the outside part, the reddish part, and the gold legends are actually made of two pieces of fused plastic. You can see the gold piece on the interior there. What this means is that they will never wear out. They're not printed on the surface or anything like that. They are literally two fused pieces of plastic. This is a very high quality way of making these caps. And it's worth noting that it's not just the primary legends that are double shot like that, but also the secondary legends with these characters. So everything on here is double shot, which no doubt contributes to the price, because look at how fine some of the details on some of these characters are. That's nuts. That's really, really cool. So this particular set of caps is made of ABS, which is a common type of plastic. Oftentimes you'll see enthusiast grade caps made of other types of plastic like PBT or POM, but ABS is a fine choice when done right. This is done right because these are so thick. We've got 1.5 millimeters of ABS plastic here, and there is no flex in these keycaps whatsoever. They are very stiff and very solid. That's going to impart a really nice, solid typing feel and sound to them. Perhaps the only drawback of ABS is that it does tend to shine up with finger oils more readily than other types of plastic like PBT. But when built like this, when manufactured to these sort of enthusiast grade standards, Both ABS and PBT are totally acceptable materials, plastics for these keycaps. You can see there's a bit of texture on here. There's a bit of texture. Not so much as to feel rough under the finger, just enough to provide a little bit of grip. And then we were talking about profile earlier. So profile is the angle, or the, well, it's a lot of things really. It's the height of the keycaps. It's the shape of the keycaps when you look at it from the side. And it's the shape of the top. It's basically the entire morphology of the keycap. These are designed to Cherry's original standards, which we call Cherry Profile. Most people are familiar with what we call OEM Profile, which is basically Cherry Profile, but a little bit taller. Otherwise, very similar though. So these are just a slightly lower profile version of what you're probably used to. And I think that's actually a great compliment to this board, because the Shift and the whole family of boards from Drop uses this floating key design, where you've got this low profile case and then everything sort of sits up on top of it. And I find that lower profile caps work better in that scenario, because there's less, like, they protrude less and there's less perceived key wobble, it feels like to me anyway. I've put some high profile caps on boards like this before. For example, I put my SA Vileplume caps on my Control, and it looks really, really good, but they do feel a little wobbly, I've found. So I think having a lower profile set on this floating key style board is a great combination. So that's enough blabbering from me. Let's start putting these caps on, shall we? So we'll keep these up here. Put the board down here. This way you can sort of see a bit of both. So when selecting keycaps for your board, the first thing that you need to make sure is that you have adequate coverage of your layout. For more standard designs, that's totally easy. Pretty much any set will cover them. For an 1800 layout like this, you're gonna have to look a little harder, because the 1800 layout has some non-standard oddities, as you'll see. Well, you can see right here, the Alt and Function keys down here next to the spacebar are a little wider than normal, and the 0 key over here on the numpad is smaller than normal. Also, the right shift is a little smaller than normal, and you have to make sure that these up here, these keys, which I think are probably actually, you know what, in the default 1800 layout, I guess they're print, lock, pause, and delete. You need to make sure that you have caps that are the right height in the profile for that top row, rather than, for instance, the delete. And I see there's an end key here as well. I don't know, we'll see. We'll see how it comes out. I can't remember exactly what the layout on the 1800 looks like up here, but we'll see as we go. Anyway, point is, for some boards like this one, you need some more specialized layouts. Now, many keycap sets will actually come with coverage of pretty much everything, from a 60% to a 65, 75, all the way up to weirdos like this 1800. But do your research with your chosen layout, and do make sure that you have keycaps that are going to fit it when you order your caps. Okay, let's keep going. So you can hear we've got a bit of pinging in this board, which is not uncommon. It probably won't be so bad once we have the whole board populated with caps here. But that's just from resonance in the metallic parts of the board. That's where something like dampening foam, like I was describing earlier, really helps. But these are attributes that you will discover with your unique setup as you assemble it, and you might find that you want to go back, disassemble, add some new stuff, and again, that's one of the great aspects of building a custom board, is that you can do that. You have the freedom to do that because you're it's entirely modular, right? You can pull it apart, swap parts out, put it back together. Whereas with something like a board that you buy, from the store, pre-built from whoever, usually you don't have a lot of options. If it's not a hot-swappable board, you're going to have to go and desolder a bunch of switches if you really want to do much of anything. And that's no fun. That's a lot of work. So hot-swappable boards really offer a lot more opportunities for experimentation and for trial and error with different setups and combinations of modifications. That's why I recommend them. Alright, so I've got most of the caps on here now. We're on to the second layer of the caps, which just is basically the numpad, and then some novelties, some fun optional caps, which I think we'll actually put on just to spice things up a little bit. But first, let's do the numpad over here. So, oops. Sometimes these things can be a little slippery, trying to get them out of their case there. One thing I like about this set is that we've actually got these divided by and times symbols here on the numpad, which is kind of fun, because it, that's honestly pretty much all I ever use those buttons for, those keys. Like, when is the last time you came over here just to type an asterisk? It's pretty much always for a mathematical function instead, right? Because that's kind of what the numpad's all about. It's for typing in numbers and equations and such. There's a dog making a noise outside. Okay. And oops. There we are. Sometimes with certain combinations of keycaps and switches, you might find that the keycaps are a bit of a tight fit. They should fit on okay, but just be careful when you're putting them on. Don't force them too quickly or too hard, because that can produce broken keycaps. You can end up breaking the sockets on your keycaps. Good quality keycaps like these shouldn't run into that issue, but has been known to happen before. So we have two options here. We have the dark gray option for the enter on the numpad, or the accent color gold. I like the accent gold, so let's put that on like that. Generally speaking, if there's an option for accent colors, I will use them because I like them. Then we've got some fun novelties here, which we can replace our shift keys with. Let's do that, because I just think they're a little more visually interesting, don't you? There we go. this one is the larger one. It goes on the left side. We've got this kind of, it looks like a cloud kind of aesthetic. And then the shorter one goes on the right shift. It's an unstabilized right shift, which is uncommon, but it's because it's shorter, because it's cut out to make room for the dedicated arrow keys here. And then we've also got some home row keys, the F and the J, the homing keys, with the little bumps on them. These are to guide your index fingers, you can see there, so that you know where to rest your fingers if you're a touch typist. And I prefer that, so let's swap these out. The default, or the stock ones, not stock, the ones on the first tier of caps anyway, do not have those little notches, those little bumps. It's really up to you though, what you prefer. It's entirely a matter of preference. Interestingly, they also offer a 5 key with the same little bump to orient you on the numpad there. So I guess for, you know, consistency, let's do that. Let's do that. Put that there. I'm not quite sure. Oh, interesting. They give us the choice here for our backslash key. We can either have the red or the dark gray. I think we'll stick with the red because I think that looks nice. But, well, you know, now that I'm looking at it, it's a hard call. I think we'll stick with the dark, or the red for now. Anyway, we also have a few options for the escape and tilde key. If we want the dark gray tilde or escape, we can. Or we have this fun escape cap right here with a character that says something. I don't know what, but you know what? It looks more visually interesting than just the regular escape. So I'm just going to move the rest of these aside and move the board in so that you can actually see that top row. Like so. Oh, isn't that nice looking? Look at that. Oh, that's looking so good. Okay, let's just take that off. Put that on. And there we have it, folks. Our completed drop shift build with the Halo True switches and the Red Suns cross drop GMK Red Samurai keycaps. I think this is looking really, really nice. A few things to point out. I did have to take a look at a picture to figure out what the default functions for these keys here are, but because again this is configurable with QMK, you can make these whatever you want, and we do have a few keycaps left over back there. If you wanted to, say, replace one of these with, I don't know, a print screen key, which I think is exactly what I will do. I don't need a pause key. I'm going to replace that with print screen because I use print screen quite a bit. Our stabilized keys, how are they sounding? Let's find out. Let's go backspace here. That's pretty good. I wouldn't say that's perfect, but it's pretty good. I'm quite happy with the enter key. The clacky sound that you're hearing is actually on the upstroke. If you listen, the downstroke, nice and soft, bottomed out on those Band-Aid strips that we put in there. And there's really no rattle from the stabilizers either. But when it pops back up, that's when we get that harsher noise. Overall, though, really happy with that enter key. Backspace. Bottoms out a little harder. Not sure if that's because we didn't quite line up those band-aid strips right, or maybe that's just the switch itself bottoming out. Hard to say. Spacebar. Bottoms out a little hard as well, but overall, the actual action of it, nice and smooth. Very little rattle. That goes for all of them, really. Oh, left shift is nice. That turned out great. Okay, well, oh, and our enter, our numpad enter. I'm happy with all those. The only one, the spacebar could use a little bit of work. It's not quite the way I like it. The bottom out's a little too hard, but it feels nicely stabilized at least. And the lubrication job feels good on all of them. None of them feel too gummy, you know? And that's important. I keep checking right shift, but that one, it's not even stabilized. So, overall, I think this sounds really, really good. I love the feel of these Hero Shrews. They're very interesting. I don't know that they're my favorite Switch ever, but they have a unique action that's it's very conducive to not bottoming out. If you push them down too far, it starts to feel like you're typing on something kind of thick and gummy. And that's because of that really high bottom out force. What you want to do is just barely actuate. Just actuate without going all the way down to the bottom. All right, well, my friends, I think we're going to call that a video. The plan here is I'm going to use this over the next little while, and I'm going to evaluate it for its typing performance, configurability, typing feel, with the RGB lighting, all that good stuff. And then I will be posting a separate video review of the drop shift and these components. Because if I tried to review this now, oh lordy, this video would never ever end. We've already got a pretty long video here. So, but I hope you enjoyed this build guide / log, and I hope it demonstrates, first of all, why you might be interested in building your own mechanical keyboard. Second of all, how to do so if you decide that's something you want to do. I strongly encourage you to consider it. It is a fun journey, and while this particular build is definitely on the more premium end of things, this is about $350 US worth of parts here, you can do very much the same for $100 or less. It just depends on what board, switches, and caps you want, but there's lots of options out there. So don't be afraid to look around a little bit, do some research, find out what's appealing for you. If you have questions about any of this stuff, please feel free to leave a comment down below. I will read them and I will do my best to answer them. Or if you are a keyboard enthusiast and you have knowledge about this, feel free to help others down in the comments who might be doing their first builds. Special thanks, of course, to Drop for providing all of the components that we used here today. You can find links to all of these down in the video description as well if you're interested in picking up any of these parts for yourself. Alright, thank you again for watching, everybody. Don't forget to check back in a few weeks' time for my review of this board. Once I've had a chance to make use of it for a while. And I look very forward to having you back here next time. Bye for now, my friends.